We're looking at some more examples of the extreme value theorem in the candidates test. Given the function below, determine the absolute extreme values of the function on the given interval. Technically speaking, when it says extreme values, those are y values. Provided the extreme value theorem is applicable. If it's not applicable, state why it is not. In order for this to be applicable, it has to be a closed interval. Check. This function has to be continuous on this domain. Also check. This is a polynomial function. All polynomial functions are continuous. We can use a calculator for this, denoted by the picture of the calculator. The first derivative of this fella is 3x squared minus 4x minus 3. F prime could be equal to 0 as long as 3x squared minus 4x minus 3 was equal to 0. This is unfactorable. Could use the completing the square or the quadratic formula, but there's no need to do that because it says we can use a calculator. Here's that function graphed. We're looking for the x-intercepts. That's when it's going to be equal to 0. So we have an x-intercept of negative 0.535 and 1.869. Notice they're rounded 3 decimal places. We always round to 3 decimal places. So I guess I should have been a little more clear here. These are the critical values, because the candidates test said we need to find critical values of the first derivative, and we need to find the end values of the graph. So according to the graph that I just had, this derivative crosses the x-axis at negative 0.535 and at positive 1.869. So we have 4 candidates. We have these n values and we have these critical values. So we make a table, x and f of x. Notice that's the original function, f of x. So we got negative 1, negative 0.535, positive 1.869, and 3. Those are the only candidates that we can choose to give us the extreme values we are looking for. Once again, this says use a calculator. So if I put negative 1 into function f, I'm going to get negative 2. If I put this first decimal in, I'm going to get negative 1.121. If I put 1.869 in, I get negative 8.065. If I put 3 in, I get negative 2. Clearly, this is going to be my minimum, and my maximum is going to be this fellow right here. Since it said to determine the absolute extreme values, the absolute maximum value is a y value of negative 1.121. The absolute minimum value is negative 8.065. Let's check out another example. Same directions. Determine the absolute extreme values. Those are y values once again. This one does not give us the freedom to use a calculator. So hopefully the calculations are going to be simple. The candidates for this, I'm just going to make my table right now. The candidates for this are going to be the n values and the critical values. We know our n values are pi over 2 and 2 pi. We don't know the critical values yet. And before I get into this, before I get too deep, can we use the extreme value theorem? Well, sine of x, that's a continuous function. If you square that, it's still going to be continuous. We're not dividing by anything that would make this undefined. Cosine of x, also continuous. If you add two continuous functions together, it's still going to be continuous. So we got to find some critical values. So according to the candidates test, our candidates are n values, which we already have, and come from the critical values of the first derivative, which we clearly don't have yet. So I take the derivative, g prime. This is the chain rule. Technically, it's a double chain because we have an inside function and another inside function and an outside function. Most outside function is squared, so we put the squared out in front. Inside function stays the same. Then we multiply this by the derivative of the inside function. By the way, I subtract 1 from the exponent. So there was a 2 here, I subtract 1, now it's to the first. So I multiply that by derivative of the inside function, derivative of sine is cosine. And then I add to that the derivative of cosine of x, which is negative sine of x. Always want to factor when we can. If we factor a cosine of x to the front, we're left with 2 sine of x minus 1. Critical values come from when the first derivative is equal to 0 or when it's undefined. This function's never undefined because there is no there's no denominator with variables in it. So when is g prime equal to 0? It's whenever cosine's equal to 0, and it's whenever 2 sine of x minus 1 is equal to 0. If we solve each of these, oh, I screwed up. Good golly, Miss Molly. Sine's in both of these, not cosine. You little rascal. So this would be 2 cosine of x minus 1 in the parentheses, which clearly changes this. Good thing I caught that now and not several minutes from now. I would have been livid. So when is sine of x equal to 0? Sine of x is equal to 0 when the opposite leg has no height, and that happens when x is on the positive x-axis, when it's on the negative x-axis, when it's on the positive x-axis again. Now, if you look at our domain, this is not in the domain. So I don't need to be concerned with that. As far as 2 cosine of x minus 1, you set it equal to 0. If we add 1 to both sides, when is cosine of x equal to a half? Well, if I go back to my coordinate plane, cosine is the adjacent leg over the hypotenuse. That would be 1 over 2. That could be in quadrant 1. That could also be in quadrant 4. So the missing side of this triangle would be square root of 3. This is a special right triangle where I should make this bigger so I can get all this stuff in. So we got 1, square root of 3, and 2. That would make this angle pi over 3, which is 60 degrees. And down here, the reference angle is the same. And the fact that this is a negative square root of 3 has little effect on us as we're trying to find the angle. This angle right here then is pi over 3. Which would make this angle here pi over 3 short of 2 pi, which would be 5 pi over 3. Both of those, well, no, not both of those. This one here is in the domain. This one here, not in the domain. Oh, look, premeditated, not in the domain. How about that, y'all? So the candidates test says that I need to use the n values, which I've already got written here, and any critical values from the first derivative. So I have to include pi, 2 pi, which I already have, 5 pi over 3. Then to figure out what the absolute minimum or absolute maximum are, I just need to figure out what the y values are at each of these candidates. And I'm plugging that in right here. If I put pi over 2 into this, sine of pi over 2, pi over 2 is going to be here. It's going to be 1. So it's going to be 1 squared plus cosine of pi over 2. That's going to be here. Cosine there is going to be 0 because cosine's x over r. So that's going to give me 1. Pi, which is over here, sine of pi is 0 because sine is y over r. So it's going to be 0 squared. Keep in mind I'm plugging that in right up here. Plus cosine of pi. Cosine of pi is negative 1 because we went left. So x is negative 1 and r is 1. 5 pi over 3, we've already got that right here. Sine is y over r, so that's negative square root of 3 over 2, so being squared. And then add to that cosine, which is 1 over 2, which is a half. If you square a fraction, you square the top and you square the bottom. Square a negative, you're going to get a positive. I'm going to change the 1/2 to a common denominator. It's going to give me 5/4. Then finally 2 pi. Sine of 2 pi is 0 squared. And cosine of 2 pi is 1. So that completes my little table. Candidates test says whichever one of those gives us the biggest value is going to be the absolute max. Whichever of those gives us the smallest value is going to be the min. So to finish this problem up, the absolute maximum value is 5/4. Where does it occur? 5 pi over 3. The absolute minimum value is negative 1. Where does it occur? At pi. First of all, does the extreme value theorem apply? This is a radical, but it's an odd root. It's a cubed root. There's no restrictions on the domain of a cubed root. So it's continuous on its domain. It's a closed interval, so this applies. So the candidates test would say that when we make our table, we have to make sure that we include the n values, and as many critical values as we can get from the first derivative is going to go between. Who knows how many we're going to have. So we take the first derivative, this is going to be a chain rule here, put the 2/3 in front, inside stays the same, subtract 1 from the exponent, will be negative 1/3. Derivative of the inside is 1. If it's a fraction, make sure you write it in fraction form. We don't want negative exponents. So from here, we cannot do anything to make f prime equal to 0. That would be setting the numerator equal to 0, and there's no variable there. But we can make f prime undefined by setting our denominator equal to 0. So I divided both sides by 3. Now I'm going to cube both sides and get x plus 2 is 0. So we get x is negative 2. So we have a critical value of negative 2. We have two n values of negative 3 and 6. We just have 3 to choose from. Let's see if we can do this calculation easily. If I put negative 3 in here, negative 3 plus 2 is negative 1. The cubed root of negative 1 is negative 1. If you square it, you get positive 1. Boom, done. Put negative 2 in. Negative 2 plus 2 is 0. 0 to any exponent is going to be 0. Put 6 in. 6 plus 2 is 8. The cubed root of 8 is 2. 2 squared is 4. You could do this a more difficult way. You could say, put 6 in. 6 plus 2 is 8. You could square it first, which is 64, and then cube root it and get 4. I just think that's a lot more complicated. This is our absolute maximum. This is our absolute minimum. So the absolute minimum value is 0. Absolute maximum value is 4. If you get scared and you think, I don't know if it wants me to give the x or y value, just give the ordered pair. And then that covers both. But when it says value, it's referring to the y value. Last one. All right, so is this continuous on this closed interval? Well, the argument has to be greater than 0. If we add 4 to both sides, we're going to get x squared is greater than 4. Now, you can't just square root both sides. You have to use a Sine diagram to figure this out. So if you focus on the boundary, keep in mind this is going to be a parabola. That's another way that we could do this. Let me just show you this real quick graphically. Here's a parabola whose vertex is at negative 4. It opens up because lead coefficient's positive. It's going to have x-intercepts of negative 2 and positive 2. Since we want, when this is bigger than 0, we would be looking for the x values to the left of negative 2 and to the right of positive 2. That makes sense? Let me look at this, going back to the boundary thing, and then we're going to try to figure out how this is going to work. According to the boundary, if we take x squared equal to 4, that's the boundary, so that's just the parabola, we would get x is plus or minus 2. If you then make a Sine diagram, breaking apart the numbers to the left of 2, between negative 2 and 2, and to the right of 2, pick a test point in each of these intervals, like a negative 4, a 0, and a positive 4. Keep in mind, right now, we're just trying to figure out, does the extreme value theorem even work? We got to figure out if this is continuous on this domain. So this has to be positive, and this is going to be positive. If you put negative 4 in to this, negative 4 squared is 16. 16 minus 4 is positive. So just like we said here, it's to the left of negative 2. Put a 0 in. 0 squared minus 4 is going to be negative. And 4 squared minus 4 is going to be positive again. So this function exists to the left of negative 2 and to the right of 2. It doesn't exist then between negative 2 and 2. And if you look, this domain it's referring to is from negative 1 to 3. So the extreme value theorem does not apply because this function only exists to the left of negative 2 and to the right of 2. There's numbers in here on this closed interval that are not a part of that. So we could say from this that negative 2 to 2 are excluded. Actually, including those. Long story longer, h of x is undefined from negative 2 inclusive to positive 2. Therefore, h of x is not continuous. I appeared to have written too large for this. H of x is not continuous on this domain up here, -1 to 3 inclusive. Therefore, the extreme value theorem does not apply. What's the big takeaway from this? You folks need to remember that the argument has to always be bigger than 0. That's the takeaway. That concludes the notes. Hopefully you learned something. Please complete the homework. Thank you very much.